Okay, welcome back for the discussion for Math 126, Section 2.2. I've had a couple of questions, so we'll dive into these. Let's start with number 8. Okay. So number 8 asks us to find a couple of values for a function. This f of x is given to us as the square root of 4 minus x. And we're asked to find f of 4, and f of 3, and f of 0, and f of negative 5. Right? So I can just start plugging numbers in, right? F of 4 means take this function, the square root of 4 minus, but instead of x, replace that x with 4. The 4 minus 4 is 0, so this is the square root of 0, and that is 0. So there's one of them. F of 3 is the same idea. I'm going to take the function 4 minus x, but I'm replacing x with 3. 4 minus 3 is 1. So I have the square root of 1, and that is 1. And done. Okay. F of 0 is to take the 4 minus 0. Right? But 4 minus 0 is still 4, so I have the square root of 4, and that's 2. Right? And then we jump to f of negative 5. So f of negative 5 is taking 4 minus negative 5. And remember, minus negative is plus, so that's 4 plus 5, so that's the square root of 9, and that is 3. Okay. And there we have it. That's number 8. Okay, 13 was next. So we jumped into piecewise functions in this section. A lot of people hate the way these look when they first see them. They're a little bit weird. But all they're really describing is that a function changes at certain points and is described by a different behavior, right? So, for example, in 13 we have the function f of x is equal to the expression x as long as x is less than or equal to 1. If not, we have it as x squared minus 1, and that is when x is greater than 1. Right? Now we want to graph this, right? So I'll graph it by hand. You would just have to pick out the graph from the options below. But what we're looking at is at 1 something happens. At the number 1 we stop being one function and we start being another function, so it's worth noting that at 1, and if you want, a lot of people like to just draw this little thing here. That means to the left of 1 I have one behavior happening, and to the right of 1 I have a different behavior happening. So to the left of 1 we're just going to ignore everything to the right, but if the function is just x, then it's literally just that line x, right? If you think about it as y equals mx plus b, if you want to think of it in slope-intercept form, 1x plus 0, it's got an intercept of 0, a slope of 1, right? But you should know what the function x looks like. And it comes up to this point and then stops, and I'm going to put a solid dot because it's valid at 1, because this is valid when x is less than or equal to 1. And so it's a darkened in spot, and then this just goes off to the left forever, so arrow down that way, right? Now once I jump over 1 for x, now all of a sudden I have a different function, right? When x is greater than 1, then it's x squared minus 1, right? And so think about a couple of spots. If x were to be 1, 1 squared is 1, minus 1 is 0. And so if it were valid at 1, I would have a spot there. But I'm going to mark it as an open circle to indicate that it's not actually valid here, right? But it's an x squared function, right? And an x squared function just kind of does this. If you want to be accurate, you could grab 2 and see what happens. Plug in 2. If x were 2, 2 squared is 4, minus 1 would be 3. So this would have to be at 3. Mine's not great, it's not accurate, or not, scaled very well. But this is what our graph would look like, right? And note that the solid came because it's valid at that point. The open circle came because it's not valid at 1. It's only valid when x is greater than 1. Okay. All right, let's look at number 14, which is also a piecewise. And in fact, if I remember right, 12 would have asked you to find some points for this, but we didn't do that. But that's what 13 is going to be, or excuse me, 14 is asking you to do. For 14, I have some function, a piecewise function that's given by 1 if x is less than or equal to 1, or x squared if x is between -1 and 1, or equal to 1 on the right, and then x if x is greater than 1. So if I were graphing this, I would cut it up into 3 spots. Those lines happen at, I think that should be a negative. It is. Those cuts in the interval would happen at -1 and 1, and then I would have 3 regions. These 3 functions fit in those. But I'm asked to find some values instead. I'm asked to find, say, f of -3, and f of -2, and f of -1. I'll do a few of them for you, but not all of them, because there's like, I don't know, 7 of them. But f of -3, in order to find out what the value is, I have to come over and see where -3 fits. Is -3 greater than 1? Nope, this one doesn't work then. Is -3 somewhere between -1 and 1? Nope. But -3 is indeed less than 1, so it fits the justification, the qualifier up here, for me to use this function. Well, the function is 1, so f of -3 is 1, because that's what the function is. Right? Same thing with, say, f of -2, right? F of -2 also fits this criteria, so it's also 1, because that's what the function is. Right? What happens when I hit f of -1? Right? Well, it's still valid here. -1 is less than or equal to -1 because it's equal to, and therefore my function is 1. Right? But once I hit, say, f of 0, the f of 0 is somewhere between these two, and therefore it's this function, 0 squared, or 0. Right? F of 1 also fits this criteria, so it goes into this function, so it's 1 squared, that's just 1, right? I said I wouldn't do all of them, but here we go, there's only 2 left, right? F of 2 now fits this criteria, so it's just x itself, x is 2, and so it's 2. And f of 3 is also fitting this criteria, so it's just x itself, which was 3 at that point. So I lied, I did all of them, there they are. Alright, thank you, and I'll see you next time.